In this video, we're going to look at the definition of quadratic functions and the main properties of quadratic functions, and also link them to the graphs of it and how you could sketch it from the GDC. So throughout the video, I'm going to assume you have access to a GDC calculator. So quadratic functions are a polynomial degree 2. What does that mean? Well, we have different polynomials. Basically, you have like terms with a variable like an x and a y or a w, whatever in there. And a quadratic specifically is when your polynomial has the highest power of 2. So we say that it's degree 2. If the variable x or y or w, whatever, has the highest power 3, then we call it a degree 3 and it's a cubic and so on. So a degree 2 means that it's a quadratic polynomial, so that's the highest power you'll see in your expression. The graph of a quadratic is called a parabola, and it could be a concave down or a concave up. And we'll look specifically at more of the properties, but this is a special way the graph of a quadratic looks like. And finally, we have the many different forms you would write a quadratic. So this is the general form, but there are other forms like the vertex form, the factorized form. And what the general form tells you is that a, b, and c are just numbers. They're any numbers, but a can't be 0. Because if a was 0, then this whole thing would disappear and it's no longer a quadratic. So it's good to be able to identify your a, b, and c throughout. So for example, if I have 3x squared minus 2x plus 1, my a in this case is 3. My b is, be careful with the sign, my b is negative 2, and my c is equal to 1. So it's good to be able to identify your a, b's, and c's. Now b can be 0, so you can have something like 3x squared plus 1, so there's no b term in there, and your c can also be 0, so it could be something like 3x squared minus 2x. There's no c value in there, but more on these forms in other videos. So what are some of the main properties? First is that you have a minimum and maximum point in the quadratic, so either it's a minimum or it's a maximum, but both these points are called a vertex. So these are the vertex of this graph. So this is the minimum and the maximum point of each of the graphs. We also have the y-intercept. So this happens when you substitute 0 into your function. And again, all of these will be explained in an example. So if I need to know the y-intercept, and that means like when does my graph actually cross the y-axis, so exactly like here. So it will have like a coordinate of 0 and then y. So to find this y, all you have to do is substitute 0 into your function. And then in reverse, we also want to look at the x-intercept. So when does my graph actually cut the x-axis? And we have like 4 of these here. Or like 2 in one graph, 2 in another. And it depends, sometimes it's not 2, but again, that explanation is for another video. So these are also called the zeros, the roots, the solutions of the function, and the way you do it is basically by solving f of x equals to 0, because you want to see what x would give you an output of 0, because these have a y coordinate of 0. So either use your calculator to find it or use the quadratic formula, which again you substitute a, b, and c from the general expression. So we're going to go through those as well. And then finally, if you notice that the graph is symmetrical, so I can actually cut it in half. And this special line that cuts it in half is called the axis of symmetry. Now we either find it by doing negative b over 2a, or if you have the roots, like the first root and the second root, you can add them together and divide by 2, and that would give you the axis of symmetry. Now, because the axis of symmetry is a vertical line, it's x equals to something. This is what it looks like, x equals to something. That's the equation for the axis of symmetry, and in an exam or like class of questions, you have to write x equals to something for the full equation, especially if they ask you for an equation. Also notice that the axis of symmetry goes through the vertex. So if your vertex, for example, has point 2.3 and 5, then your axis of symmetry is x equals to 2.3, because that's the x value here. So again, we'll be shown through an example. If we have this example, we need to plot this graph and we need to show the main properties. And the properties you need to show are basically these that I'm mentioning on the left-hand side. So we're going to use the GDC first to graph it. I'm going to go to y equals, and as you can see, I have it written here. To get that x, you just have to press this button. So once I have it, I'm going to graph the function. Now this is not what it looks like. You might have to adjust the window. Like after adjusting it, I realized I need x to be over to 20. And I realized that y had to be decreased, so from negative 30 to 15. So you have to play around with the window just to get the full graph. So first we notice that it's a concave down, but let's see what one of our steps is to see the intercept. So let's look at the y-intercept. So in order to do that, remember that for the y-intercept, your x is equal to 0. So I'm just going to go to second, calculate, and I'm going to go to value. And I want to see what output will I get if my x is equal to 0. And that's going to give me negative 18. So when x is equal to 0, y is equal to negative 18. And it's highlighting the position for you. So if I have let's do the actual axes. So obviously you want to use a pencil for this one, or on a ruler, just to make sure that your axes are accurate. And we're going to point out so we have the y-intercept here as negative 18, and we have something like this. So we have the general shape of the graph, and this is 0, negative 18. So we've shown the y-intercept. Now we have the x-intercept. Again, either using the quadratic formula, we can substitute the a, b, and c in the quadratic formula, or go to second, calculate, go to 0, and this is when you want to know when is your y equals to 0, so be careful. We need the left bound. It means go to the left of the 0 of the x-intercept, press enter. Now you need the right bound, so you need to go to the right of it, press enter. Don't make it guess, press enter again, and that's going to give you 3, 0. You need to make sure that your y is equal to 0, so 3, 0, which means that my first coordinate here is 3, my first root. Repeat it again for remember you need to go to 0 and not value. Value gives you like the y output. For 0, we need the x value. So this is the left bound of the second root, and then right bound, press enter again, and it's going to give you 12, and y equals to 0, which means this is 12. So this is our second root. And so we found this and this. We need the max. In this case, we have a maximum point, so we need the vertex. Again, we're going to go to second, calculate. We're going to go to maximum value. And again, we're going to take the left side of our point. So this is the left of it, and this is the right of it. Doesn't matter how far you go, but as long as you're close to it. Press enter, and you're going to get 7.5 about for the x and 10.125 for the y. So this is 7.5 and 10.125. Okay, so this is 10.125. So we got the coordinates of the vertex, we got the axis-intercept, and we got the general curve of the graph. Now the question also asks for the domain and range. So the domain is basically all the values I can put into the quadratic function. For a quadratic, it's always x in the reals, so it's all the values. Okay, so this is for quadratic functions. For the range, y belongs in the real values, but specifically, let's look at the y-axis. You'll notice that there's no y output, there's no curve beyond the 10.125. There's nothing here of my curve. My curve starts from 10.125 and it goes lower. So my output is anything less than or equal to 10.125. And this is a general thing. If you have your vertex, your y will always be either less than or equal to or more than equal to 10.125. And you can see it from the graph itself. So you'll notice that your output only starts from 10.125 and goes down. So this is where the curve exists. So this is the range. Now, if I want to expand it a bit further and also talk about the axis of symmetry, so again, either using the a, b, and c values here and substitute in the formula. I could also notice that the axis of symmetry goes through the vertex, so it should be 7.5, or use the roots here. So my roots are 3 and 12, so 3 plus 12 divided by 2, that's 15 divided by 2, which is 7.5. So I can say that my axis of symmetry is x equals to 7.5 if the question asked for it. Hopefully this is clear. These are the main properties you should know about quadratics, and when you're graphing it, these are the properties you should show. Also in the graph, make sure you show a couple of do a scale, so do a proper scale, show a few values. It doesn't have to be accurate, but a rough estimate, and showing all of these intercepts are important.